Good morning, good afternoon, good evening, namaste. I am Vinay Mistry. I would like to welcome you all to Oracle Groundbreaker Yatra, AIOG's Oracle Groundbreaker Yatra 2020, an online web series. It is being a day full of knowledge till now. This is the seventh session of the day. AIOG is one of the largest users group webinar series covering around 14 days for 125 hours of learning, 100 plus sessions, 100 plus speakers, 60 plus Oracle aces and Java champions. Every day we are hosting 8 sessions starting from 10 a.m. to 10 p.m. with adequate breaks. Always refer our website aiog.org for accurate timings. These are today's speakers. We had great speakers today, and we have got many great speakers lined up for next few days who are going to share their knowledge. AIOG is one of the largest Oracle users group in APAC. Sangam is our yearly annual conference that is held either in Hyderabad or in Bangalore every year. We sometimes thought, why not to make it available to all cities? That's how we started Yatra. Yatra brings the speakers from all around the world in different cities across the India. Last year, we visited 10 cities, but due to the global scenario this year, we have gone online. It is actually a blessing in disguise that this year we could get more speakers from all around the globe. I'm going to hold this slide for a moment, maybe for a few seconds. Take a print screen or snip the image and share it to your social media. Tag it with hashtag OGYatra to show your support to the user group as well as to the speaker for giving their valuable time. So let us now welcome Leo. Leo is an Oracle ACE director. He is a senior Oracle DBA consultant with more than 20 plus years of experience. During these years, Leo has worked as a senior consultant with large number of companies in various fields and have managed different Oracle practice services teams. He mainly specializes in HA solutions, performance, backup, and recovery. Leon is president of British Columbia Oracle Users Group. He loves traveling and skiing. His Twitter ID is on the screen. Please feel free to connect with him over social media. Make sure you ask questions in the Q&A panel only. Depending on the time, speaker will choose questions. If time does not permit, don't worry. We will try to get the answers from the speaker and post it to our AIOG portal soon. With this, I would like to invite Leo to start with this session. Leo, you can share your screen now.
Okay, thank you very much. So let's do this.
Leo, can you hear me?
Yeah, I can hear you. Can you hear me?
Yeah,
Hello?
we can hear
okay.
you. Go ahead and share.
Okay, so I'm just sharing my screen now. Okay, can you see that?
Yep.
Great. So last thing, I'll just turn my video so you can see me as well. Hello, everybody. So thank you for the introduction. It's actually my first time talking at the Groundbreaker Yatra. So thank you for accepting my sessions and having me. My name is Liron Amitzi. Here are my contact information. So you have email, Twitter, and my website. And also, I'm on LinkedIn if you'd like to look me up and connect or follow me in any way. So I'll start by introducing myself. Okay, so I'm originally from Israel, which is the small purplish area here in the Middle East. And almost 5 years ago, me, my wife, and kids moved to Vancouver in BC, Canada. And this is where I am now. So it's practically the other side of the world than India. And that's, I think, 12.5 hours difference. So it's 7 a.m. here, and it's 7:30 p.m. In India. And today is July 1st. And if you don't know, July 1st is Canada Day. And Canada Day is like the Independence Day in Canada. So I just wanted to say happy birthday to Canada, 153 years old. So a little bit more about myself. I've worked with Oracle database since 1998 and Oracle 7. I'm a senior database consultant, and I've been doing that since 2002. Here in Canada, I'm an independent consultant, and I'm working with all kinds of different companies and all kinds of different projects, from database design, SQL tuning, to infrastructure topics like DR, data guard, real application clusters, whatever, anything basically in the database area. I have my own website and blog, so go to DBA. You are welcome to go there and check the content. I have a technical blog there, but not only. I have some other stuff as well. So if you're interested, you're welcome to go, take a look, subscribe if you want. I've been part of the Oracle ACE program since 2009. And earlier this year, I got promoted to Oracle ACE Director. So that was a great honor. And last but not least, I'm very involved with Oracle user group community. And here in Vancouver, I'm currently the president of the BCOUG, the British Columbia Oracle User Group. So that's about me. And let's start with the session. So my goal today is to open your mind. We're going to talk about schema design. And my goal is not to just give you information, but open your mind to the different things we can do with schema design. The session will be divided into two. The first one will be about 15 minutes. I'll talk about the goals and the components, let's say, of database design, what it means, how we do that. And the second part will be actually designing a schema. Okay, so I'll present you with a challenge, let's say, and we'll design the schema together. We'll see different designs and pros and cons of each of the design. So the idea is to just open your mind into different options to understand the benefits and the downsides of each option, and just discuss that. So that's my goal for today, and I hope it works. So the schema design goals. Why do we need schema design? What the purpose? So first of all, when we're designing a database, when we're working with a database, the goal of the database is to store and retrieve data. Okay, and the schema design of our application is very related to this. So if I create a set of tables, for example, that can get all the information you need as fast as you need to put it into the database, but after that, you can't really get the data back or query it in a reasonable way, we miss the point, right? So we need to design the schema so we can store the data in a reasonable way and then retrieve it in a reasonable way as well, okay? If on the other hand, we can retrieve the data, so we can do any SQL you want and any filter and any condition, and everything works just fine and it's very easy to use, but we can't insert the amount of data, or inserting the data that we want is very complex and needs a lot of processing or something like that. That also breaks the idea. Okay, so the database is there to store and retrieve the data. So we need to design the schema in order so it will be easy and reasonable to store it and also retrieve it in a reasonable way. Okay. Data integrity. In some cases, not all of them, and we'll talk about that a little bit. In some cases, we want to we want to make sure that the data is intact. Okay, we don't want contradicting pieces of data. We don't want, for example, if we insert all kinds of data from different sources, but they contradict one another, if we query that, we don't know which one is true, right? So we need mechanisms to keep the data correct. Okay, make sure that no invalid data is entered, or how to verify if the data is correct, or if there are relationships between different pieces of data, make sure that this relationship exists and intact. Okay, so that's another goal. Performance, obviously. When we query the database, when we insert, when we update, when we do anything on the application, on the database side, we want it to perform well. What is well performed? That depends on the requirements. And we'll talk about that as well. But performance is definitely a goal of when we design the schema. And the last thing is flexibility. In some cases, we would like to have a schema that is very flexible. We can add, change, or I don't know, move things around and change the schema design during the time that the application is running. And sometimes we don't want to do that. Sometimes we will want to have a more strict structure without changes. And again, this is based on the requirement. I didn't put the word here, but this is basically, all of this is based on the requirement of the application. Okay, so this is very important to understand the requirements and then design the schema that will fit these requirements. And this is what we're going to do basically during this next hour. So what is schema design? What does it include? So that was supposed to be an in-person session. Obviously, it's not. It's online, so I'll answer these. But there are 4 things that I wrote here, and these are basically clues for them. So the first thing is data types and values. When we and I'm going to talk about each of them separately. But data types and values, when you design the schema, when you design the application, you need to decide which data types to have in the tables, and something about the values as well in some cases, and we'll talk about that in a second. The next thing is, if you guessed, indexes. The next thing would be tables and table structure and normalization. And the last thing is constraints and triggers, so we can keep the data integrity. So let's talk about each one separately. Okay, design your columns and data. So this is an example of a table with the name of the city, the low temperature date, and the low temperature in Celsius. And you can see the create table here at the bottom. So there are 2 interesting things about this. Okay, and this can definitely be a real case scenario. So there are 2 strange things about this design. First of all, the data types. Okay, as you can see, the low temperature date, even though it's a date, it's configured to be a varchar in the database, and the low temperature in Celsius, which is obviously a number, is also a varchar. So this is the first issue here. And there are many sessions and many articles about having the wrong data types in the table, and it's very highly not recommended. But this is a problem with things like ordering and validation, that it's actually a number and a date and not just text that someone entered. So ordered, I said, and the last thing is performance. Okay, this may cause optimizer problems. So this is something that we usually we wouldn't want to see in the table. But there's one more thing that is strange here in the table, and this is these values, right? So as you can see in Vancouver, the lowest date was the lowest temperature date was 1968 and minus 18 degrees. In Mumbai, it was 1962 and 7.5 degrees. By the way, this is true data. This is correct. But in Tel Aviv, that's not a valid year, right? And that's not a valid temperature in Celsius. In some cases, we'll see people insert like the system or the developers use an invalid data or an invalid value to represent specific situations. Like in this case, we can say we don't have this information. So I just insert an invalid value, and the application knows that the invalid value is actually, I don't know. So again, I've seen people do stuff like that. It's not really recommended, okay? But this is something that we do at the design stage. And there are two problems with doing such a thing. First of all, it messes up with the optimizer. And second, if other applications use this table, they have to know that what you mean here, okay? So in general, it's better to use null in this case. Null is a generic term for I don't have this information, okay? But I've seen all kind of invalid values to represent other stuff, and you need to think about that when you design the schema. Another example, and this is real example, I saw that a while ago, maybe 15 years ago, but this was a real example. So we have a table called events, and we have a year, month, and day. And they are also varchar in this case, which is, we said it's not a great thing to have, but this was the case. But that's not the problem. The problem is the data itself. I would expect in this case to see a year, 2020, a month, January, a day, 1, right? This is the logic that I understand from this table. But the data itself looked like this. So the year was 2020, but the month was 2020 January, and the day was 2020 January 1. So we have redundant data here. So it takes more space than it should, and it messes up with the optimizer. And we also have an integrity, data integrity issue. If for some reason the application had a bug or a problem or something, and we updated only the month to be 2019 January, this is data integrity problem, right? The year is 2020, but the month is 2019-01, and that's a data integrity problem. Okay, so we want to avoid these things. And in this case, by the way, the problem, again, it was long time ago, and we had a performance problem with a query on that. And it was quite complex to write this query again, as well, because they wrote it wasn't complex, but the query was strange because the query included all three, the year, the month, and the day, and it didn't make any sense, and it messed up with the optimizer. So when you design the schema, this is something to think about, okay? All the data, the data types and the table structure and the values that you use in the database itself. Next would be indexes. So indexes is I would say it's not the less important, but it's the least important thing to talk about when we first design a schema, because this is the thing that is most flexible. Okay, we can create indexes, we can delete indexes pretty much on the fly without affecting the system too much, and we don't need to change the application when we add an indexes. So when we add indexes, so this is relatively something that is more flexible. But when we do design indexes, and I'm not going to talk a lot about indexes, we can talk about indexes for hours. But the general thing is to think about the index type and see the pros and the cons of each type, and then decide which one to use. You can use bitmap, you can use bittree, you can use function-based index, and then you can use composite index with multiple columns, and the order is important with the composite index. Okay, so it's important to understand these index types and then decide on which column or columns we need indexes, and then we can create them. Again, this is something we can do after the application is online, and that's relatively inexpensive to do. Unlike the other stuff that we need to change the database and sometimes the data itself, which is a very heavy operation. And sometimes with that, we need to change the application, which makes everything more complex. How many indexes should we have? So that's a good question. If we have too few, maybe queries will not run fast enough. But if we have too many, we might affect DML performance. So insert, update, and delete. Updating many indexes will have overhead on the system. So that's also a balance that we'll need to do based on the requirements of the application. And the last thing is autonomous DB. We hear about autonomous DB all the time. And with autonomous DB, Oracle had introduced the feature of automatic indexing. So basically, the database sees what you do and create indexes for you, delete indexes that are not needed, and so on. So this is awesome. And maybe in the future, we won't need to, think about indexes at all. But for now, that's a new feature. It's still immature. It has lots of limitations, and you can go on and look for information about that. And maybe in the future, when it will be mature, maybe we'll be able to drop this slide and say, okay, indexes is not a very important thing because the database is doing that for us. Next, normalization. Okay, so normalization is a huge topic, and I was debating how much to get into this now, but I decided to have the second part of the session a bit longer and discuss the designing a schema together. So I just have 2 slides about that. And the concept of normalization is splitting a table into a few tables based on the objects in the table. And there's a lot of information about normalization, and there are formal ways of normalization, and people learn that in computer science degrees and stuff like that. It's a whole thing. But the general thing, again, just an introduction. It's splitting a table into a few tables based on the object in the table. So in this case, this is the employee table, okay? And we have the emp ID, we have the name of the employee, we have the department, the city, and the state, okay? But if we want to have more information about department is a different entity than employee, right? So we'll split this table into 2 tables. Employee, that's one entity, and departments is another entity. So basically what we do is create a new table and just point from the department column of the employees table, we point into the department table. So now we have 2 departments, IT and sales. And if we want, we can add on more information for departments, okay? So we can have more information like location of the department, like maybe a department manager, maybe some other stuff. Which doesn't make sense to add into the employee table, right? If we want to have a department manager, we want to have location of the department, we would like to have some more information about departments, it doesn't make sense to just add more columns to the employee table. So we split that up into the departments table, and then we can have all the information there. And also we can do the same with the city and state, okay? So in this case, I split the entity cities from the entity employee, and I just pointed. I just add like pointers here from city to the cities table. And I can do the same with states, okay? Take the state and split it if I think it's a different entity, okay? The basic split like that is called a lookup table, and we'll talk about, we won't talk about lookup, but I'll mention that soon. So the basic thing to take the department and just split it into a different table, it's called just a lookup table. And I take the name, the ID, which is internal, and I take the name from here. And in other cases, it's not only a simple lookup, it's really a new entity with lots and lots of other information about it. Another example for table normalization, or maybe an incentive to do that. So a city called Grover City in California, in 1992, they decided to change their name from Grover City to Grover Beach. Okay, so if in the previous slide I had everything in the employee table, okay, I would have to go and update and run update number 1. So update the entire employee table and set the city where it's Grover City to change to Grover Beach. And that's updating, that will update as many rows as employees I have living in Grover City, right? So if I have 1,000, it will update 1,000 rows. However, if I split that into the cities table, I will have the employee with some internal ID in the city ID, and then I'll have the cities table with all the information about the cities. And then I will need to run update number 2, which is update cities and change from Grover City to Grover Beach. And this is only 1 row. Okay, so that's an incentive to do something like that. And in some cases we want to do that, and in some cases we won't. We'll talk about that in a second. And the last thing is data integrity. Data integrity is the triggers and constraints. And the concept is to enforce data types and values. For example, if I have, in my first example of the temperature, lowest temperatures in cities, if I had the temperature as a number, people won't be able, even if they want to, they won't be able to enter letters there. While as long as it is varchar, they can do that. And maybe I don't want them to do that, so I can have a specific data type that will enforce that. Values is the same. I can define the range with constraints. I can define, you know, whatever I want. Also, I can use constraints to enforce parent-child relationship. So if I take the example of the employee table, I have the employees table, and then I split the departments into a different table. And in the departments, I can have the department manager, as I said. And if I have that, I can force a check that the department manager is actually an employee, an existing employee, and not just, you know, a random thing that doesn't translate to any employee. Uniqueness, of course, or not null, and triggers. We can use triggers to keep data integrity. In some cases, the constraints are not enough, and we want something more complex, some more, you know, complex logic. We can definitely use triggers for that if this is required. And one last thing about that, the concept is to keep all the data integrity constraints and logic in the database, because if we do that on the application side, first of all, there are bugs, and I've seen that. And if we have time, I'll talk about that a little bit at the end. And second of all, if there are few applications, that would be duplicating the code in order to keep the data integrity in the database, which doesn't make sense, because if one of the developers in the new application forgot to do that or wasn't aware of that, that's going to break our application, right? So we want to keep that in the lower layer, which is basically the database, as much as we can. And one last slide before we get to part 2 of the presentation. A simple example, simplified example. That again, this is very simplified. Let's take the classic, very classic OLTP, online transaction processing system, versus the data warehouse system, and let's see a little bit how the different requirements or different characteristics of these two systems affect the design of the table or the things that I said. So OLTP versus data warehouse, again, the very classical implementation of them. So saving space, I'll talk about saving space when we talk about designing the schema a bit later. But saving space in OLTP, we want to avoid duplicates, mainly if we want to change them, like the Grover Beach, Grover City example. We don't want to have the name of the city duplicated. In data warehouse, we don't care about that. Actually, sometimes we do want to we even want to have duplicates, and we will compress them. Okay. Regarding data integrity in OLTP, it's more important. We want to make sure that all the data is correct and there's no contradicting information. Data warehouse usually takes all the data from different systems. And if we assume that the different systems have the data correct, we don't need to check that. Or if we want to check that, we can check that during the loading process. And usually in data warehouse systems, the data itself is read-only. We're not updating the data very regularly. So if we don't update the data, there's no reason to check for data integrity in the database. We can do that in the loading process and forget about that, right? Nothing is changed, so obviously the data is still intact. Normalization. In OLTP, we would like to normalize data. We would like to separate different entities to different tables. In data warehouse, we usually denormalize data, okay? We consolidate data into a few huge tables and not having to work with lots of different smaller tables. Contention in OLTP, because of all the changes we do in the database, update, delete, insert, we want to avoid contention. Many users are working with the same tables, the same data. We don't want them to work with the same blocks and have contention and lock each other. In data warehouse, everything is just querying. It's usually irrelevant. And usually there are much less users that working concurrently. We just run reports or something like that. And last, performance. In OLTP, we would like to have instant response. Okay, if I'm working in front of a screen and I'm working with the system, I want to click a button and see the results immediately. In data warehouse, if we talk about reports might take a while, and that's fine. If we have a yearly report and it takes overnight, that might be okay. So even performance, and I said that at the beginning when I talked about performance, everything is subjective, right? Everything depends on the application requirement. Okay, so that's about it. And let's start with the second part. So let's design a schema. Okay, so this is an example that I want to present to you the problem, and that's a very simplified problem, but it can be examples for much more complex scenarios. Okay, so this is the example that I want to present, and I actually like to ask that in interviews when I'm interviewing either DBAs or developers. Sometimes I ask that, and that's a nice question to see how people think about this stuff. So we have a chain of stores called Books and More. Okay, that's obviously something that I made up, and we would like to design a software for that. So Books and More have 3 different types of products. They have books, they have magazines, and they have audio, and that's it. Okay, and each one of the products have these attributes or properties. Okay, for example, books have author, title, date, number of pages, and price, and so on and so forth. Okay, I'll just highlight the common properties. Okay, so we have common properties that all products have. That's title, date, and price. And then each product type has 2 unique properties for that product type. So books has authors and number of pages, magazine and publication frequency, and audio has musicians and the number of tracks. And now let's discuss how we would model this information. Okay, so think about that for a few seconds. And I talked about lookup tables before. Okay, forget about lookup tables. I don't care about lookup tables in this specific scenario. Okay, so for example, author here. Let's have author in our schema design, and if it's a lookup or not a lookup, I don't care about that. Okay, that's easy to decide if we want to have a lookup for that or not. But forget about lookups for now. How many tables would you use in order to represent all the products for this system? Okay, so think about that for a few seconds. We prepared a poll for that. Let's see if I can start the poll. Yeah, okay, so I'm going to start the poll. I'll give you a few seconds to answer. How many tables would you use in order to represent this schema? Okay, ready? Okay, let's go. I'll give you a few more seconds and then we'll share the results. Okay. Oh, where is the poll? Okay, people are still voting, so few more seconds. Okay, we got almost 50% of the people voted. Okay, and let's end the poll. Okay, I'll show you the results. These are the results. So most of you said 3 tables. Some said 2, 4, 5, and only a little bit said 1. That's interesting. Okay, so what I want to do next is go over different design schemas, schema designs, okay? And we'll discuss each one. Okay, so the first option is one single table, okay? And I just want to explain this color code that I have along this example. So the white columns here are the common ones, okay? And then the colored ones are the unique ones for the products, okay? So the red ones are for books, the blue ones are for magazines, and the yellow ones are for audio CDs. One last thing, I had a discussion with a friend who's colorblind. So he always preach about having, colorblind people. They don't see the difference in colors sometimes. So I decided to have in parentheses here the originating product. Okay, so the red ones will have B for books. The blue ones will have M for magazines, and the yellow ones will have A for audio. Okay, so this is just the coding of this, so it will be easier to understand what comes from where. So single table. Okay, that was the least popular option in the poll. We have one table with everything. So books will have all the common properties full, and these two are full, and the 4 that are irrelevant for books will be null. And audio CDs will have the 5 common ones full, and the 2 yellow ones full, and the 4 in the middle will be null. Okay? That's a very valid design. One big happy table. The benefits of having that is that it's very, very, very simple. And it provides good performance. Now, this table might be large, and we'll talk about that in a second, but if we do have one table, once we get to the row that we're looking for, that's it. We have all the information. We don't need to bring anything from anywhere else, right? So that provides quite a good performance, and it's very simple. The bad things is that we have contention. Everything is in the same table. If we want to update something, we'll have to update this table. If we want to insert and delete stuff, everything is from this table. This table, the same indexes, and everything is basically at the same area, which cause contention and is not great for OLTP systems. Another downside, if you want to change something or we have a problem with the table, that's basically a full downtime. Okay, we won't be able to access anything. Everything is like all our eggs in the same basket. If there's a problem with the basket, everything is gone, right? So that might be a problem. And when I want to change the schema, even if I want to add something only for books, I affect the entire table, right? So with Oracle, everything can be online, and we can have all kinds of different mechanisms to not take the application down during this time. But still, as a general rule, we're going to touch this table. That's affecting the entire application. Also, unnecessary scan of irrelevant data. If we want to search for something in the table, for example, we don't have indexes, or we would like to get a lot of information, Oracle might decide to perform full table scan. So if I want to search something or run a query that performs full table scan, but I'm interested only in books, full table scan scans magazines and audio CDs as well. So that might be a problem. Let's check the next design. 3 tables. Okay, so I think that was the most popular solution. So this is very simple as well. We have 1 table for books, 1 table for magazine, 1 table for audio CD, and that's it. Okay, we have all the information about books here. We have all the information about magazines here, all the information about audio here. Very simple and straightforward. 3 tables. Pros and cons. It's simple. Relatively good performance, the same reason, because if we want to look for books, everything is there, right? We don't need to get information from anywhere else. Access only a relevant product. Okay, so if I want to do some aggregation or something on all the books, I access the books table and everything is there. I don't access anything else. I don't scan irrelevant data and everything is good. Changing the structure of one product is easy. If I want to add something to books, audio CDs and magazines are not affected. I can do whatever I want in books, and even if the books table is locked and nobody can change that, still magazines and audio CDs are still available. And we have less null columns. Now, this is not really a benefit. You know, null columns don't take a lot of space. Sometimes they don't take it all. Sometimes they take a little bit. But what's the problem here? When we have one big table, okay, if we have lots and lots of information, the table becomes very, very wide with lots and lots of columns. And at some point, this causes a problem. There are articles about that, I think, over 240 or 255 columns, something like that. Oracle starts to do crazy stuff. Okay, so if we have a very wide table, very big columns, big rows, that's a problem as well. So in this case, we keep that to the minimum that we need. So that's a benefit. The downside, if I want to add another product, okay, I need to add a whole new table and change the application to access this table. Okay, that's quite a few changes. Querying all products. Let's say I would like to see all products that cost less than $5. Okay, I will have to scan 3 tables. Okay, and if I have another product, I need to change this code to scan the 4 tables or 5 tables and so on. So every change that I do, I need to add table and I need to change all the querying. Also, what happens if I know a title of a product, but I don't know what type it is? Okay, so I will have to search this product in all 3 tables. Okay, I don't know if it's CD, book, or magazine, so I will have to scan all of them, which is a bit of a hassle. So let's check the next design, 4 table. Okay, in this case, I did exactly what I did in the example about normalization. I took the 1 table and then I split the entities out. I took the books out, I took the audio out, I took the magazine out. So now I have items table, okay, with all the common properties. And I have other 3 tables, 1 for books with only the extra columns for books, and then 1 for audio with only the extra columns for audio, and 1 for magazine with only the extra columns for magazines. Okay, so I have 4 tables in this case. And let's see the pros and cons. First of all, this is a very straightforward RDBMS design. Okay, very simple to summarize common properties. If I want to check, if I want to sum all the price of all my products, it's easy. I just go to the items table and that's it. If I want to search for an item with unknown type, like I had before, it's very easy because all the common properties are in the items table. So I just look for the title in the items table, and I know which type it is, and then I can go to the books, magazine, or audio if I want to. I don't even have to do them. The downside: queries require more joins. Now, join is not a problem in general. With the RDBMS scenario, in an RDBMS systems, in relational database systems, joins are something that we'll always use, okay? And this is great. We love using joins. But the problem is, as I go and split more and more tables, at some point we're in with lots of joins, like 10, 15 tables, and I've seen stuff like that. That becomes a hassle. That might be a performance problem, might be more complex queries to manage. So in general, as we have more joins, we might have more problems as well, okay? So once we start splitting the tables but keep some of the data shared, in very complex scenarios, we'll have many joins, which is a little bit of a problem. Not a huge problem, but still. It's performing, let's say, worse or not as good as one single table. And adding another problem, we still have the problem of adding adding another product. We still have the problem of adding a product, because now we, again, need to add a table and change the logic of the application to use this table, and so on. So let's see the last schema design. Oh, not last, almost last. 2 tables. Okay, so we had 1, 3, and 4, and now we have 2 tables. So 2 tables is items and properties. Note that I don't have all the table. So we have property name and property value. In this case, I have a book. ID 1 is a book. The author is Stephen King. Number of pages is 7,000. If you read Stephen King, you know what I put 7,000 here. He writes long books. So these are the properties of books, but these are 2 different rows in the properties table. And then item 2 is CD, and the property name is musician, and the property value is pink, and so on and so forth. So I'll have a huge table here with lots of rows, and that will represent all the properties of all the extra things we have in the system. Okay? This provides amazing flexibility. Okay? We can add another product. We can change the structure entirely on the fly without doing anything to the table structure, only the data. The problems is it's very difficult to enforcing constraints. Okay, and it's also very different. It's complex when we're working with different data types. I'll go back, and you'll see that here we have a number and string in the same column, so we can't have any constraints or any special data type here on the property value. In some cases, I've seen people splitting that into property value text, property value number, property value date, but that becomes even more complex. Okay. And last thing, have you tried querying that? Okay, so let's see a few queries. And I'm running out of time. Okay, so we'll finish that, and that will be the, I think, the end. We'll see if we have time. I have 2 additional slides at the end. We'll see if we have time. If not, we'll go to the Q&A. So querying that, a very simple query, specific author. I'm querying the ID from the properties table, okay, where the property name is author, the property value is Stephen King. That will give me all the rows of books with author Stephen King. I get all the IDs, and then I go and query the items to see all these books. Okay, that's great. Now that's getting a bit crazy. I want to get a specific author or number of pages. Okay, so I do the same, but now the property name and property value are either author Stephen King or number of pages 7,000. This will give me all the IDs in the properties table. Okay, so all the rows with author Stephen King and number of pages 7,000, I'll get all these rows. I take all the IDs and I query the items. And this is really nuts. Okay, so I want a specific author and a specific number of pages. And this is problematic because the property table, in the properties table, these are two different rows, right? So I can't have the property name is something and the property value is something, and then the property and add and end with property name and property value, because these are two different rows. So I have to query all the authors Stephen King, all the authors Stephen King, and the number of pages 7,000. I'll get all the rows, and then I do a group by here and say, give me all the IDs that have count *2, which means they have both of these. Okay, and then I can take the ID and go and get the items. So that's quite difficult. And if you go to even more difficult scenarios, this is practically impossible. Okay, so only if you have very simple queries, you can actually use that. The last one is a single table but different. Okay, and actually I told you I used this question in interviews, and one of the interviewee said gave me this this solution. He said all the comments here, all the common properties here, and I have other info with JSON, and the JSON has all the special properties. So it's very easy for developers to handle. Okay, JSON or XML or whatever you want. You can have that, the programming languages use that, can handle that, no problem at all. It's extremely flexible, but it's not really an RDBMS. It's not a relational database design. Okay, you cannot enforce anything by definition. JSON is very flexible, so you cannot enforce anything. Okay, so I would recommend using that in some cases that you need the flexibility, but not as a general design of the system. Okay, an example for the JSON with support for JSON data type, it's really easy. Select from all items where other info.author is Stephen King, other info.number of pages is 7,000. It's very easy. So which one is the best? We saw 1, 2, 3, 4 tables and the one with the JSON. I intentionally added to the poll 5 or more. If your 5, the people who answered 5, if you don't include the lookup tables, okay, I couldn't think about 5 table design, but if you have one, I'll be happy to hear. You can send me an email or tweet or whatever you want. So which one of the 5 examples is the best? 1 table, 2 tables, 3 tables, 4 tables, or the one with the JSON? Like everything in our world, it depends. And it depends on your requirements. Performance requirements, flexibility, data integrity, querying, and the space. Okay. One last comment before we go to the Q&A. I had a colleague a few years ago, and we were both consultants, and we worked with different clients, and we faced a similar question. Okay, it's a similar design issue. And eventually we decided to go to completely different paths. So for my client, because we had very limited resources, and we wanted to be as fast as possible, and just when we queried the row, we wanted everything to be there without looking at the tables. We went with a one big happy table design. And my colleague, because he needed the flexibility, they wanted everything to be completely flexible without the need to change anything in the schema, they went to the completely to the extreme other solution, which is the two table with the items and the properties. Okay, so basically everything is based on your requirements. Okay, and if we have time, we'll go through this. You can check the slides later. Let's go to the Q&A. I hope you enjoyed the session. Again, these are my contact information. Feel free to contact me or follow me on Twitter. So let's go and see the questions. Okay, I'm reading the question. Generally, as per business applications requirement, we design schema, but do we have to follow any rules? Is there any popular tool available to design schema? So in order to design the schema, the tool that provides you, SQL Developer can do that. It's not actually SQL Developer, it's like a tool from the same family. It's called, I forgot the name actually, but there is a design tool from the SQL Developer family, so you can use that. But are there any rules? No, there are no rules. It depends on your specific requirements. Okay, so I tried to give you all kinds of different examples for requirements and solutions, and you need to do the balance yourself. Next question. We mostly faced issue while trying to redesign third-party code or vendor code. Oh, that's a good question. Usually when it's a third-party vendor software, you can't really change the design. You do have some tools to change the you do have some tools to change the SQL code if needed, but you can't really change the table design, right? Okay, let's see, next question. Can we have one big table with partitions based on books, magazine, and audio? Of course, I didn't want to get into partition issues, but that's definitely an option. Use partitions or use other Oracle tools to overcome all kinds of different design problems. Yeah, partitions is definitely, if you have enterprise edition and you have partition license, that's definitely an option. Okay, but still, if you partition based on the type, you have to know the type. If you don't know the type, you will go to the entire table, right? Oracle will scan the entire table. Next, adding another item is easy as you need to add another table with a different ID. How is this difficult? Yeah, it's easy to add another table, but you still need to change the application in order to query this table. And I don't remember which solution was that, but if we talk about like solution with a 3 or a view on these tables, if I add another table, I need to change this view or change this code of the union. It's not difficult. It's one more thing that we need to consider. We need to work with that. Okay, so that's something to remember when you do something like that. Too much normalization kills the performance, correct. That's why I said that in the 4 tables design, we have joins, and that's what I meant. Too much normalization will require more complex queries with more joins, and that's a performance killer. That's true. We have 2 minutes. Do we have time to answer more questions?
I think it's better we take it offline because we have to plan for the next session coming up.
Okay, no problem. So I'll try to take these questions offline and answer, and then we'll see how we provide you the answers, but I'll do my best to answer everything.
Sure.
Okay, so thank you very much. I hope you enjoyed. And I have another session on July 15th. So I hope to see you there as well. Thank you very much.
Thank you, Leon. Can you please unshare your screen?
Sure. There you go. Bye. Bye.
Okay. So let's. Okay. I hope my screen is visible.
Yes.
Okay. Thank you, Leon, for your insightful session. Leon is having one more session on 15th of July on real life SQL tuning. To join that session as well. You can see his Twitter ID in the screen. To connect with him, also connect with other attendees through OG Yatra Twitter pages. We will push some interesting questions on AIOG websites soon, so we can, we can continue these discussions over there. So this is our learn and win section of OG Yatra. You attend more session, you earn more points. 1 minute you attend, 1 point is what you earn. So you have already earned 60 points after attending this session. Also, we have bonus points on your social media activities. Please do check delegates newsletter, which was sent to your registered email. Now you must be thinking, now what you can do with these points. So you can get AIOG membership based on your recognition level, what you achieve based on your points. You can check benefits. You can check the membership benefits on AIOG website. So just go to aiog.org/join us. You'll be able to see the benefits. You will get an OG Yatra patch, which you can share it on your social media accounts. Also, we will provide a certificate of participation. So please continue your conversation in Twitter. This is the only way we can connect to different people virtually at this point in time in these situations. The presentation material will be available after Yatra. You will be able to access them through AIOG portal itself. We have special and surprise programs being planned on 4th of July. Do not miss. Do join. We have keynotes. We have got fireside chats. We are also planning to have discussion with ACES and Java champions of India in one call. They will share their journey and experience. 12th July is dedicated to Kids Track. This is the one popular program we did it last year also, and it's now being part of OG Yatra. Speakers feedback, it is very, very important for us. It is very important for the speakers so that you get better sessions every time you come to OG Yatra. Please spend 2 minutes of your valuable time and provide the feedback. Nevertheless, as we said, we are hosting Kids Track. It's going to be on the Sunday, 12th. Registrations are already started on aiog.org website. Please go ahead and register there. With that, thank you, Leon, for your continued support. Thank you for everyone for attending. Our next session starts approximately in 30 minutes by Rish Nimit, a very good session, a very good speaker. Do attend. Thank you very much. See you in 30 minutes.